you by Math with Janet. I'm Ruby Moore.
I'm Charlie Moore, and today's activity is solving Supernova Math Mysteries.
Specifically, today's activity is going to focus on the Crab Nebula. Using these two images, we are going to try to find when the supernova happened. First, we're going to learn what a supernova is.
Long story short, a supernova is basically just a star when it explodes. Sometimes a supernova could cause a black hole, but if it's not strong enough, it will leave back a remnant with a pulsar and clouds of dust and gas that slowly move away from the dense version of what the star used to be.
Obviously, there's a lot more that goes into it, but for this activity, that's the knowledge that we need to know to find when this supernova occurred.
Now, these diagrams are pretty complicated, so we're going to start with some simpler diagrams before we get to this.
The Crab Nebula is an actual supernova remnant, but these are supernova simulations that will help us to practice before we get to the Crab Nebula. This image was taken in 2019, according to the simulation, and this image was taken in 2020. In the image taken in 2019 and 2020, we both have a pulsar, which is that supernova remnant. And we also have 3 dots, which are made of gas and dust that we can track through space.
While we work, we're going to use this light table. If you're doing this at home, you probably don't need a light table. We're just hoping that it will help us see better on the video.
Our challenge for today is to analyze these 2 photos and find when the supernova that made this remnant occurred.
So Ruby, how do you think we can analyze these images to help us find the answer?
Well, we know that these were taken a year apart, and in the later years, our first picture was from 2019, and you'll notice that the pulsar stays the same in both years, but the gas and dust particles, the 3 that we tracked, slowly get farther and farther away as each year goes forward. So, to track when it started, we'll have to go from the latest picture taken back. To help us with this, we can, if we line these up, because the pulsar stays in the same place every time. So if we line up the pulsars, then we can find how far the dust and gas went from the last year.
All right, so I have an idea. How about we take a piece of paper, a different piece of paper, and we take this and we go back until we hit the pulsar.
That's good.
And then see how many years it took for that.
We have index cards, which will help us to space out the difference between 2019 and 2020.
Alright, so
Find the different years.
So we can mark it's there and there. And then we can take that right there. Mark this little spot. Okay. And then back there it should be like that.
We've hit the center of the pulsar, which means starting here, we went, this was 1 year, this was 2 years, and this was 3 years.
All right, so we started from 2020, 2019, 2018, and then 2017, we were back at the pulsar. So let's check the other sides to make sure. So it's like we're using the index card like a ruler, but we're not measuring inches. We're measuring the length of the different time periods that the gas moved. As we move back towards the pulsar, it's like we're rewinding time from when the gas moved, and we're going back until when the pulsar was a full star.
We've now reached the center of the pulsar, with our markings. And again, it took 1, 2, 3 years to get back there.
So 2020, 2019, 2018, and 2017, just like we tracked on this side. So with this, we're pretty sure that the supernova explosion occurred in 2017.
We are ready for supernova remnant B. Let's put these on a light table.
So you'll notice that this picture was taken in 2018 and this picture was taken in 2020. They're 2 years apart, so there would be a 2019 in between. Do you want to figure out what the 2019 where it would be, or do you want to continue going back from 2018?
Continue going back, I think, will be the most efficient for finding when the supernova happened.
Okay. Now you can do whatever you want. This is just our decision. All right, and now let's move it back. In the one before, it would represent 1 year ago, but now these are 2 years apart. So that would represent the 2 years before 2018. So this would be 2016, right there. Right. Then move it back like that. So again, this would be 2016, this would be 2014. And then this...
The pulsar?
Yes,
that's the pulsar.
That's at the pulsar. So from this, it's saying that the pulsar, that the supernova occurred in 2012. So let's check the other side. All right, and we're back at the pulsar. So again, it would be saying that the supernova occurred in 2012.
We've gotten 2 lines done, and since they both match up to the same year, we are pretty sure that we're ready to move on to the next one, knowing that the supernova occurred in 2012.
I think we're getting pretty good at this. So let's skip C and let's go to a real challenge, D. All right, so this was taken in 2017 and this one was taken in 2020. So that's a 3-year gap this time. Do you want to?
All right. And this dot to this dot is a 3-year gap, which means when we find the next dot in the line, it will also be 3 years.
All right, so that's from 2020 to 2017. And what's the next gap?
2014.
And then we're back to the pulsar.
Wow. We've made it all the way back to the pulsar. What date did we reach?
So we went 2020, 2017, 2014, 2011, 2008, 2005, 2002, 1999, and then 1996.
Based on the tracking that we did on this line, all the way down to the pulsar, we've tracked that the supernova happened in 1996. Let's check one more line to see if we get the same results. Alright, and we've reached the pulsar again. We got the same result this time, 1996, starting from 2020, going back 3 years every new dot that we reached. The pulsar still stays at 1996, and since we've gotten 2 out of the 3 lines completed, it's our best guess to say that the supernova occurred in 1996.
So now we have a different diagram, and it's from 2020 to 1983. Now, you can always do these at home, but we think we're going to tackle the Crab Nebula next.
The Crab Nebula has pictures from 1956 and 1999. This diagram looks a little bit different than the others, considering it's definitely more detailed. We have more than 3 points of dust and gas.
Okay, so remember that all of this started at the pulsar, and when the star exploded, it sent gas and dust flying everywhere.
You'll also notice that we have tick marks. Each tick mark is numbered. Right here we have 1 that goes all the way to 10. These tick marks inside, in between the different tick marks, are space, or areas of dust and gas that we can track movement from. Can't quite find the pulsar, but we can find it right here. All right. So we have the pulsar lined up.
So I can definitely see 3 here and here.
Yep.
Once we have it lined up, we want to find the space in between sections 3 like we did on the other ones. So how should we do this? Like that?
This is what we're tracking. We're gonna have the angle lined up to the center. The centers.
Well, that's like a best guess because I don't have it on the thing.
Yep. Since these images didn't come with a straight line, we're gonna also use this index to double as a straight edge. I'm not going to move the paper because this is our route from the center of the 2 tick marks to the center of the pulsar.
Now that gives us a path to follow as we trace back time. So this distance represents 43 years because that 43 years is the time gap between 1999 and 1956. So every time we move this, we go back 43 years. I don't really want to count back 43 years every time. So let's just see how many times it takes to go back to the pulsar.
Okay. Okay, and now we've reached the pulsar.
So, how many times did it take us? So we're counting how many jumps of 43 we had to make.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it took us 15 jumps, each of 43 years of rewinding. Let's write on the board and find out what 15 times 43 actually is. All right, so we got 645 as our answer to 15 times 43. So wait, is our starting date 1956 or is it 1999?
Is it 1999?
Yeah, because
yeah.
so it would be 1999 minus 645.
So what does all of that mean?
So we started at 1999, which was when the most recent picture of the Crab Nebula that we have was taken. We subtracted 645 years because we knew that each gap, every gap that we made was 43 years. We ended up having 15 of those gaps. We learned that 15 times 43 was 645. Then, by taking 1999 as our first date, and then subtracting 645 years, we got 1354, which is when we think the Crab Nebula was a supernova.
We only tracked one section of gas and dust. If we wanted a better estimate, we would repeat the process for the others.
But we're going to leave that up to you. For now, this has been More Math.
Brought to you by Math with Janet.
Thanks for playing math with us.